So our next speaker, who's going to give us more of a on-the-ground perspective, is James Kerr. He brings a wealth of experience when it comes to owning and managing sheep and cattle properties across Australia. He's the manager of Buckleboo Station, and he has focused on reversing the decline of grasslands and bush country with a strong commitment to long-term sustainability and regeneration across his entire property. So he's got some fascinating results from what he's done. So that dedication was recognised in 2024 when Buckleboo Station won the South Australian Landcare Award for Sustainable Agriculture, and he's now a proud finalist in the National Landcare Awards, which is happening in September. So congratulations. James, come up onto the stage.
Thank you, Annabelle. Thank you for the opportunity to present our Buckleboo Station story on regeneration and carbon farming. What I'd like to do today is just a quick introduction and then talk about regeneration as an overview, the carbon project, the monitoring tools that we're using, and lessons, observations and takeaways. Buckleboo Station is owned by Dr. Ray Dennis. We have 250,000 acres. We trade as Pirie Pastoral Company. Our average annual rainfall for the last 100 years has been 322 millimetres. We currently run a Dorper self-replacing flock. I would actually just like to dedicate my presentation today to my brother who passed away less than 2 weeks ago. In 2020, at the end of the last drought, he was helping us. And he said one day that this place looks like a moonscape. That is what the property looked like at the end of the drought in 2020. On the left-hand side and on the right-hand side was the previous drought in 2008. I guess that was the motivation to change direction. We never want to see the landscape in this condition after future droughts. The direction that we're taking is to build drought resilience through regeneration. Our direction has nothing to do with climate change. We accept the degraded ecological state of the property. We plan to resolve that degradation of the ecology, and we're committed to that plan. The next major drought will be in 2031-32, and we will be ready. This chart is a tool that I use, and I've used for many years, and I find it, I could spend the next 25 minutes just talking about this chart, so I can't do that. But when you'll notice, this is the solar cycles going back for the 300 years. And you'll see that those cycles are incredibly consistent. They range between 8 and 14 years, and they average 11 years. So 11 years from the peaks and about 11 years from the troughs. So there's the last drought, and there's the drought beforehand. And the next drought will be in 2031-32. It's a good guide, and it's one that I've used for years, and I'll continue using it. Our 100-year average annual rainfall has been 322 millimetres, and you can see we're predominantly winter rainfall. In 2020, we did a comparison of the 100 years to the last 20 years, and we noticed there was a small drop-off in the spring. But in the last 5 years, we've had very good spring rain, so if I was to do that chart again now, there'd be absolutely no change. If you look at our rainfall since 2018, pretty much average annual rainfall, except for the 2 drought years, 2018-19 and the beginning of 2020. And then last year we only had 186 millimetres, one of the driest years going back to 1915. And this year we've actually now had 164 millimetres year to date. So we're well behind the 8 ball again this year. To look at this drought resilience planning, we decided to regenerate the whole station, change our grazing management, have a sustainable long-term sheep grazing business, restore badly depleted native grasses caused from set stocking, take a holistic approach to our planning, focus on ecological regeneration, which is increasing the biodiversity, focus on total grazing pressure, which is the sheep, goats and kangaroos. We worked with Richard Marver to put together an ecologically sustainable rangelands management plan. It's our Bible, and we refer to it all the time. We've split the property into 6 40,000-acre paddocks. I'll explain that in a bit more detail in a second, but over the next 10 years, we plan to split all those paddocks in half again. What we've done since 2021, we've put all the Dorper ewes into one mob. The station has been divided into 6 40,000-acre paddocks. Approximately 40 kilometres of internal fencing has been constructed. Each paddock is grazed for 3 months. And then by the time we do a lap around the station, each paddock gets 15 months complete rest, or, if I coin that a different way, 15 months of active growing. The stockyards have been enlarged and new facilities have been constructed. Every watering point has a trap yard, and goats have been removed off the station. So let's looking at regeneration. There's 5 essential ecosystem functions. The solar energy function. This is focused on maximising the capture of solar energy by fixing many plant sugars through photosynthesis as possible. The water cycle, focused on the maximisation of water infiltration, storage and recycling in the soil. Soil mineral cycle, focused on inculcating biologically alive and healthy soils to contain and recycle a rich load of diverse minerals and chemicals. Then there's the dynamic ecosystems. This is focused very much on biodiversity and the health of integrated ecosystems at all levels. Human social function, which is focused on the humans triggering landscape regeneration by working in harmony with natural systems. So the true cause of degradation on landscape functions is not the cloven hooves, but the mouths of livestock. In other words, overgrazing. Too many mouths set stocked. Grazing pressures too hard and too short for far too long. This method destroys many of the green leaves, the solar panels of the plants, thereby starves the energy production system of the plants and killing many roots. This in turn leads to a cascade of dysfunction, including the degradation of the water cycle, which is infiltration and storage, associated destruction of the soil life and ground cover, escalating erosion, the collapse of the nutrient cycle and dynamic ecosystems. Buckleboo prior to 2020, we've been set stock for a very long period of time. Sheep, goats and kangaroos, which I call the total grazing pressure, these 3 species seek out the most palatable grasses first. And over time, this constant grazing pressure eradicates those plants from the landscape. This was evident across the station, as we only now have low-quality speargrass. Bluebush and saltbush overgrazing near the watering points, a lot of bare ground across the station, and deep erosion across the station. Many years ago, I saw this quote, and I think at the time when I first saw this, I just didn't believe it. But now this is actually central to everything that we're doing and the way that we think on the property. Droughts don't cause bare ground causes drought. So let's look at the carbon project. The carbon project is managed by AI Carbon, and you can see by this heat map that it covers pretty much most of the station. That's one of the reasons we have to take a holistic approach towards it. In 2022, AI Carbon came out and established 54 transects across the property, and that's where they do the measuring of the carbon project. So we've got a human-induced regeneration carbon project. These projects change land management practices to facilitate regeneration of native forest. The management practices include excluding livestock from a project area, managing the timing and extent of grazing, is what we're doing, managing feral animals and non-native plants, and stopping activities such as mechanical destruction of natural regrowth. And it's maintained for 25 years, which is the permanence of our project. So the human-induced regeneration method is suitable if in areas where grazing activities have suppressed tall shrubs and tree growth, where it has forest potential, and the timing and extent of grazing to allow these areas to regenerate. And the actual forest potential is to have 2 metres or more in height and a crown cover of more than 20% of the land. Other areas that are sequestered carbon is not rewarded, and that is that regeneration or suckering of existing trees that are already over 2 metres and more than 20% of coverage, regenerate of soil crust and the lack of hoof erosion, regeneration of shrublands that cannot meet that forest cover of 2 metres, and reduce methane from reduced stocking rates. Co-benefits that are not rewarded, as well as biodiversity, water infiltration, soil stabilisation and the improvement of land management. Soon I'll show you some slides of exactly what's happening on the station, and all of this sort of reverts back to the co-benefits of what we're doing. So when you look at a project design, you've got the area, which is where the transects were set up. The yield is measured, which is a CSIRO carbon model method, and then of course the spot price. AI Carbon has about 32 projects across South Australia, Western Australia, New South Wales, and a lot of their projects are actually in the pastoral country of that 200 to 300 millimetre rainfall. So when we start looking at these HIR carbon projects, it's about regeneration. So if you look at the tree at the top, you'll see that that tree is intact, but when you look at the ones down below, you can see the hedging effect or browse effect from goats, where there's just no vegetation at the bottom, and a mushroom type of effect. And then the plant down on the right-hand side is almost hedged. It's like a bonsai, very thick on the bottom, but just been eaten off all the time. And even government agencies, everybody's now pretty much on the same page that grazing pressure removes native grasses, shrubs and small trees and prevents the recruitment of new trees to grow simply because they've been grazed all the time. So here's some evidence of grazing impact. You can see the stump effect, which I was talking about, like a bonsai, where you've got a thick stump and just been hammered by sheep and goats and kangaroos. Broken branches, the hedging effect, very thick at the base and dead flat across the top. And then you've got the browse line with goats. And goats, 55% of their diet is browsing, and they have the ability to remove all foliage up to about 1.8 metres. So they do a lot of damage. AI Carbon have adopted very detailed technology and LiDAR technology, which is all done through 3D modelling to work out the height and canopy masking. The LiDAR technology it's a very accurate digital twin to benchmark the future. It's fast and efficient, remote access for ecologists, farmers, regulators, auditors, and fantastic technology. I mean, here's just an example of the LiDAR in a backpack where they just walk along that transect, and it just measures everything from all the vegetation from the very short grass right to the tops of the trees. So the ecological identify the species, collection of high-resolution LiDAR capability with intricate detail, enables the calculation and actual volume, providing integrity over the traditional volume calculations. It's ground truthing, taken and compare. Samples are taken away for testing, and here's just where the samples are taken to a lab. 12 different range species were sampled. The known volumes were recorded. The samples were dried for 72 hours and then weighed. The basic density was recorded, and then that density was compared with literature on similar species. The density and the volume were used to obtain the biomass. So it's just the detail of the technology is quite extraordinary of the way it's been measured. And the heat maps on the right there is the biomass volume and then a carbon volume on the right. I'm flipping through these because it's just very technical, but if you need to speak to the AI Carbon guys in more detail, I'm sure they'd be more than happy to discuss it in more detail. Just to give you an idea, in the time that AI Carbon's been analysing Buckleboo, there's been 16 billion height location data recorded on Buckleboo, just in the last couple of years since the project's been up and running. So an enormous amount of data has been collected off the property. Let's start looking at the pricing of carbon into the future. It becomes a commodity price, like it fluctuates with supply and demand and government policy. There are some projections there with ANZ. Currently the carbon price is around $35, $36 a tonne. ANZ's forecast that by June 2026 it could be up around $75, and then CBA's forecast that by financial year 2030 around $85 a tonne. And then there's even a projection there by financial year 33, $142 a tonne. We'll wait and see where that pricing actually ends up. But just to give you an idea, this is a very conservative yield projection of our project. Just assume $80 a tonne or $80 an ACCU. We're looking at roughly 28,000 tonnes a year over the term of the project. And then when you look at it always starts at zero. And so over time, the project yield will build up. This is probably conservative. It's hard to tell. I'll show you some satellite images of our biomass of what's happened in 4 years, and I can only assume that we've seen such enormous change that over time that yield could well prove to be quite conservative. But we're looking at around $50.1 million revenue over the life of the project. So the forecasting, I've asked AI Carbon to come up with the low range over on this side, mid-range, and what AI Carbon's done here is locked in at year 10 about $81 right through to the end of the project, which is an average of around $81 a tonne. But with supply and demand issues, as I was saying before, it could easily, high end of the market go right up to $145 a tonne. We'll just wait and see. So with this forecasting of ACCUs, this modelling is based around forecasts released in March 2024 in the Buckleboo project. And all of AI Carbon's projects, we want to be conservative, and we feel comfortable about that as well. The revenue estimates maintain the same ACCU value from year 10, but many in the market apply a 3% year-on-year increase. So as I said, by sticking to that flat rate from year 10 just gives us probably a conservative average. Note that the pricing reflected in the pre-setting table generally does not account for the potential of co-benefits which might be attributed with the ACCUs. These benefits are typically associated with the project outcomes from biodiversity and the advancement of social licence. I won't go on to the next one. It's just that the ACCU market is primarily driven by the compliance market, and Sarah was touching on that just in her presentation. So here's some evidence of some of the regeneration that's occurred. The photo on the left there, all of that new vegetation has come up in the last 4 years since we removed goats from the property. The one on the right is bullock bush. That's one of the most palatable trees on the station. We use that as our main indicator tree, and you can see quite exciting regeneration happening in the bullock bush. Here's some regeneration evidence with western mild trees. The one on the left has been eaten. It's got that hedging effect, and the one on the right is flourishing. So with our carbon project, in 2024, this is just the progress to date. 2024, we had 54 transects established across the carbon area. We've developed a 10-year management plan with AI Carbon. We've got native title consent from the Gawler Ranges Aboriginal Corporation. We've just recently completed 15 kilometres of fencing. This is part of the additionality as per the management plan. And we've had our audit completed in March. We also have a big carbon project in our New South Wales properties. At this stage, it's with the Clean Energy Regulator for final approval, but it looks like around 170,000 tonnes in our first audit. It's very exciting. So with the monitoring, I want to go through this in a little bit more detail. So we're using scarce satellite tags to monitor the livestock of movements around the paddock. We're using NDVI satellite monitoring. We have soil probes to measure the moisture available to plants in a range of different soil types. And we've set up 12 monitoring sites around the station so we can monitor what happens inside and what happens outside where there's grazing pressure over the long term. So here are the scarce tags in the sheep's ears. They were cattle tags, more designed for cattle. And over time, they actually worked their way out of the sheep's ears, but they were amazing, absolutely amazing what we learnt from those tags. That is 24 sheep in 1 month in a 40,000 acre paddock. And you can see those 24 sheep really did move and cover a lot of the paddock. Here's 2 sheep over 3 weeks. One was the blue and one was the orange. So they're incredibly mobile, and it's extraordinary how much of the country they actually cover. So there's our heat map over about 3 moves, so about 9 months, I guess, in that. But you can see that they pretty much use That's only 24 sheep out and the mob. They pretty much cover every square inch of the paddock. This is where it starts to get interesting. With the NDVI monitoring we're doing on the property, this just gives you an idea of how valuable it is in a pastoral setting. That paddock was, when we were putting the sheep in January, there was 1,049 kilograms of dry matter to the hectare. 3 months later, when we took them out, there'd been 2 inches of rain, but there was still 1,018 kilograms of dry matter to the hectare. What we were then able to do was to integrate the scarce tags so we could see where the sheep actually grazed in the paddock. And then if you go back to the previous slide, you can actually see that where those sheep were grazing is where the most change occurred on the paddocks. So it's probably no surprise to everyone here that my goal for Buckleboo is to have no bare ground. What I want to do now is just show you what has happened. This is using SIBO Labs biomass monitoring, and red is less than 250 kilograms of biomass to the hectare. So we do this in January every year because January being the middle summer month, and because we're predominantly winter rainfall, it just makes sense to do this in the middle of summer month. So January 2018, January 2019, January 2020, January 2021. Now that's the year we started making the changes with the carbon project. But you can see there's still a lot of bare ground across the property. 2022, change was starting to occur. 2023, after the big year, we had a lot of rain in 2022, but the satellite doesn't lie. It just reflects just what changed. 2024, you can see the red is starting to disappear and it's a lot lighter. But just remember, in 2024, we only had 186 millimetres, which was the driest year since 1915. And in January 2025, despite having that really dry last year, we've now increased our biomass to 1,400 to 1,500 kilograms of biomass to the hectare. So it can be done. Soil probes. We've got soil probes in different soil types across the property. The one in the cage, I've got a Bluetooth on my phone and I read that one manually, and we're trialling some satellite soil probes as well. So there's the two that are inside the monitoring yard, one's inside and one's outside, see if there's any change in the soil moisture. So these are some of the observation yards that we've been building around the property. The lessons and takeaways from this. One thing that I really noticed is when our biomass built up a lot, it affected water flow. The last decent rain we had was in December 2023, and after 4 inches of rain, I hardly had any water in my dams. So the runoff effect was, well, it's what we were trying to achieve. We were trying to improve the water cycle and keep the moisture on the country. That worked really well, but we couldn't get any water in the dam. So the last 12 months, I've just had the grader going flat out to improve that. So one of the risks with the carbon project is fire. We keep our roads graded and all our fire breaks and roads. It's a lot of country. I've got 640 kilometres of roads around the station, so we're constantly at it. We've set up an army truck for a big firefighting unit. These are where you start to see the evidence of what's happening. These are the comparison photos. So that was the first photo I put up of the moonscape 2 years later in exactly the same spot. That was the photo I put up at the start in 2008, and that was exactly the same spot in 2023. Another comparison photo was in April 2020 at the moonscape stage of the cycle, and in 2023 it had changed quite dramatically. So these couple of photos are just before we put stock in that paddock last year. That it had 14 months complete rest. You can see all the blue bush and salt bush is in full leaf. These photos were all taken about 5 kilometres apart. So there's no change right across the whole 40,000 acres. It just looked absolutely fantastic. So last year we were very honoured to win the South Australian Land Care Award for Sustainable Agriculture. Fingers crossed next month when we go to the Gold Coast for the National Award. Key takeaway messages. Planning is essential. A detailed written plan that is adopted by everyone in the business. Commitment to this plan is extremely important. Carbon projects require long-term partnership arrangement with your project manager. Choose carefully and ask lots of questions and always seek independent advice. The opportunities to build drought resilience through ecological regeneration will provide long-term sustainability. The carbon project provides external investment or revenue to assist with this process. View your ecology as natural capital, the engine room for your future. Thank you. If you'd like to follow us, we do have a Facebook page on Buckleboo Station and Pirie Pastoral Company. Thank you.
Wow, James, that was amazing. Where are you? I can't get over the science and the tech that's involved in what you've done. Has anybody got any questions to kick things off?
Sorry. The reason I need to say it, James, you'll know it, the AI guys know it. You can't put that same project in anymore. That particular method has been sidelined for now. Hopefully it might be in the integrated farm and land management method. However, unfortunately, you can't repeat the amazing things.
Yes, that's true. I guess this is part of some of the speakers have actually raised this today, the frustrations in this process going forward. There's been a lot of work done on the nature repair bill, and the integrated farm management process will take over, I guess, in the future from the HIR, because what it will enable us to do is to have a much broader measurement across the whole property. So instead of just being the regeneration, then hopefully biodiversity will start to come into it. And you can see by those slides we've had a very big increase in biomass. So I'm quite excited that at least we've probably got a foot in the door. We've made all the changes to the enterprise, but we're very fortunate to have 1 million acres over in New South Wales as well, and a lot of goats there. What we're doing in Buckleboo, we're doing across all our New South Wales properties, but it's challenging. You know, it's a lot of country, a lot of goats, and our thinking is changing completely. Like, we're already talking about the next drought. We're making plans of how we're going to manage the drought in 31-32, not just on Buckleboo, but all across all the New South Wales properties, because it's made us realise that we're committed to the carbon projects, we're committed to the regeneration, not just on Buckleboo, but across the whole group, and therefore we can't make the mistakes that we made in the past, where we hold stock on for too long, you know, thinking it's going to rain next week and it doesn't, and it keeps going. We can't make those mistakes again, because we want to. The regeneration is very, very important for long-term sustainability, but by getting involved in these carbon projects, to us is just completely changing everything. I think the way that we're looking at our business in the future.
And the amount of investment, I can just imagine. Can you give us an insight as to how much has been spent on this particular project?
It's true. I mean, yes, we've had to spend money to split the property up and to make sure we had very good boundary fencing, to make sure we had very good internal fencing. That's just essential to try and keep the goats out. We have gone, I think, one step further, putting trap yards around all the waters so I can make sure that I can control the watering points. But just remember that that's also adding value to the property. I mean, if you've got a really well-graded roads, really good fencing, trap yards everywhere. Just to give you an idea with the trap yards, when I first started there in 2018, we had a plane in the air and 6 motorbikes on the ground. It took us 3 weeks to muster the property. We do it in 4 days now. Every time I move from one paddock to the next, it's all over in 4 days. So the productivity gain in putting trap yards right across the station has been absolutely tremendous.
Has anybody else got any other questions for James? Yes.
Hi James, how are you? Thanks so much for your presentation. We've heard a lot about carbon credits today and it's really great that you are having such success with your project. I'm really interested with your practice change. You would have started to notice a lot of different species come back that perhaps you haven't seen before. What's been some of your favourite species that have started to come back in the landscape?
Yeah, so what have been some of the species that you've seen come back into the landscape since you've started making the change?
I'm not an ecologist, actually. I'm going to admit something here. I moved to South Australia 8 years ago. So I tend to, well, I'll get to answer your question in a second, but I tend to look at the big picture. And that's why I feel that the service of someone like Richard Marver, who was a rangelands ecologist, when Richard first came out and sat down with us, you have to be really prepared for what he said. I mean, and it was quite a shock. I mean, you know, the initial assessment. But what we're finding is that by making the changes, there's mallee bluebush has popped up, and when I first started there was virtually none around the station, but it's evident everywhere. The grasses that we really want, that I want to see come back, are the really good native grasses, and at this point there's not a lot of evidence. We've seen some wallaby grass. To me, the kangaroos are putting a lot of pressure on the grasslands, because goats and sheep, particularly dorpers, will browse shrubs, bluebush, saltbush and the trees, whereas the kangaroos rely purely on the grasslands. So I did need to do more work on that from the species, from the grasslands perspective. But with the saltbush and bluebush, one of the things that we've really noticed is how much seed we're getting on those plants, because they've been rested for 15 months and the plants are in full leaf, so becoming really, really productive. And I'm hoping over time that with more input from ecologists to help us sit down and really understand the change in species over time, because we're only 4 years into the project. So I think, like with everyone, the message I can send everyone, that there's a steep learning curve in all this, because you really do need to zone in and focus on the ecology, and by making these changes, bringing all that extra carbon into the soil, of how much that improves the soil health. And I think over time, what we've done is set the starting point. It's just going to get better and better from here on.
I think we have to leave it there. Oh, have you got one more question?
Just a quick one.
Yeah.
James, quick question for you. In terms of your downstream supply chain, so your customers, what's the response been from your customers of your product? And as an extension to that, what role do downstream customers have in terms of assisting pastoralists to make this change? So the people who buy your product, what's their response been?
So the customers, yeah. So you're meaning in regards to customers?
So the people who buy your meat.
Sheep meat.
Yeah.
Mm.
So for the in terms of being carbon neutral,
in terms of the impact you've had, so you've demonstrated with this presentation today a massive impact on the landscape. What's the customer of your sheep meat seen as a response? What's their response been to you?
I understand where you're coming from this one. One of the things that with our sheep that's really concerned me is, we run a dorper business, and because of the quality of the grasslands and the pastures and everything, we've actually been sending our lambs pretty much straight off Buckleboo down to one of our properties down in the southeast, so that we can get a better finish on the lambs. One of the things that that we're not getting direct feedback back from customers yet as such. But I do personally believe that we were organic. To give an example, we were an organic property, but we chose to drop the organic side of it because I think there's going to be more and more demand for carbon neutral type products to the market, just based on we've been even hearing that today. And so as we go forward, not only on Buckleboo but on our New South Wales properties, we do need very soon to stand up and say we are carbon neutral, simply because of the amount of credits that we'll have, and then try and position ourselves in the market for that. I mean, I'm even trying to work out how we can brand our carbon as well. I mean, there's not many people in the market doing that, but if you do it really, really well, then why can't you establish a brand for your carbon product? You know what I mean? And I think if the nature repair bill comes through and there's a broader approach to it all, that those that want to brand their carbon, similar to branding their stud bulls or their rams or whatever, why not? And I see that as probably one of the very big opportunities into the future, which we aren't even talking about now, is to have enough yield, do it really well, and brand your product into the market. That's a big opportunity that I see.
Well, that's my takeaway. Thank you. Branding your carbon. Thank you very much, James, and congratulations on everything that you've achieved there at Buckleboo Station, and it must be so satisfying to see the results.